Today we're doing 8.3 Advanced FTC, which means the fundamental theorem of calculus. And we're just going to be doing it with graphs, okay? So just like on 8.1, we're going to be doing geometric figures. And I'm just going to make the notations of the integrals look a little mean, okay? So let's get started. Okay, so you should know how to do this function right here. I have here a graph with just geometric figures, just like before. And we've already actually found the areas of all these. We did it in the last one. Let's just find the areas real quick again, so I don't have to worry about that after we start talking about the integrals. The area of this is base times height. That's going to be -2. The area of this is base times height, which is 1 times 2. And then you divide by 2 because it's a triangle, so that makes it -1. This triangle is base, which is 2 times a height of 2, all divided by 2, which makes it 2. This is a pi r squared divided by 2, has a radius of 2. So we plug in 2 here, we get 2 squared is 4, divided by 2 is 2 pi. That's this entire semicircle. And this is a base times height, 2 times 2 divided by 2, makes it an area of 2. Okay, now we got all the areas here, so let's actually focus on the integrals. Okay, now you guys should know how to do this integral from 0 to 4 if I only ask for the f of x portion. You should know how to do this right here. If I throw a -1 into there, you might not know what to do. Now remember, what the -1 does is it just shifts things to the right by 1, right? That's a transition formula. Now what we're going to do is these values right here, they're x values. And this is subtracting 1 from the x. So instead of shifting a graph over, like you might want to think, we're actually just going to mess with it in the integral notation here. So instead of putting 0 to 4, we're actually going to just go from 0 minus 1. So from -1, oh, it looks like my pen went off. So from -1, it's too close to this little thing. Here, I'm going to have to write over here, okay, guys? We're going to go from -1 to 4 minus 1, which would be 3. And now instead of calling it f of x minus 1, we can call it f of x. And finding the area from -1 to 3, that would be from here to here. And the area is just this semicircle, which is 2 pi. Now, if you would have tried to do it like this one, from 0 to 4 of f of x minus 1, first of all, if you would have noticed from 0 to 4, maybe this little triangle would be easy, but doing this weird portion of a circle would be quite more difficult. So you wanted to figure out how to deal with this -1 before doing the problem. Okay, let's do a different one here. We got a 3 now in front of the f of x. Now, just like in the past when we were doing integrals, this 3, this constant, it can either stay with the f of x or you can move it outside if you want to. So this can be rewritten like this, -4 to -1, f of x dx. Now, so that means that you guys know how to do the integral from -4 to -1. That's just going from here to here and getting the area, right? And all we're going to do is we're going to get that area and we're going to multiply it by 3. And so if you see a coefficient in the front here, that shouldn't be a very difficult thing to deal with. So let's get the area from -4 to -1. That would be -1 plus 2. So that's going to give us this entire thing right here. This whole thing is all going to be an area of 1, and we can just multiply it by 3, so 3 times 1 is 3. And that's going to be the answer to this integral right here. Okay, let's go on. Now I'm just going to rewrite those areas in here because they're going to be the same. So -2, -1, 2, 2 pi, and 2. Now let's mess with this one here. I have a constant out in front, and I also have a +2 inside of the function here. So let's try to get rid of this +2 because that's going to translate the function to left 2, right? Well, let's just do with that over here with my integral. 1 plus 2 is going to be 3, and 3 plus 2 is going to be 5. So now I've gotten rid of that +2, and this 5 that are out in front here, I'm just going to take it outside of the integral. And I'm going to have the f of x dx. Okay, this function looks much more like something we've been doing. You can find the area from 3 to 5. From 3 to 5 is just going to be an area of 2, and we're just going to do 5 times that area, which is 2, and that's going to be 10, and that's going to be that integral. Okay, here's one that's a little more difficult. They're putting a plus 5 outside of the parentheses. And so the way to do this is, and I've told you guys this several times with whenever you have multiple terms, is you're dealing with each term separately. Okay, so basically one way to think of this integral that they have here is go from -4 to -1. Let's take the 3 on the outside and put it on the outside there. F of x dx, that's one integral. That's that first term. And we'll do this other one separately, -4 to -1 of 5 dx. Now notice to find this area of the function, that's going to be looking at this graph. From -4 to -1 would be from here to here, which would be -1 plus 2, which is 1. So this area right here, that's 1. And we're just going to multiply it with 3. So this entire first term here, the integral of this first term, is going to be 3. Now dealing with this 5 that's over here, doing an integral with 5, that's not going to be dealing with this graph at all. That's going to be doing boost and divide like you guys know how to do. And so if you boost and divide this, it's going to be 5x. And then we would put brackets around it. We're going to go from -4 to -1. And then you plug in your upper bound, so you'd have -5, because -1 times 5 is -5. You plug in, subtract, and plug in your lower bound, which would make -20. And that turns this thing in the middle here, that makes that a plus, right? And we got -5 plus 20, which is 15. So the area of this, when you do the integral with that, it's 15. And then you can just add them together. 3 plus 15 is going to be 18. And that is the integral for that.